Uh, okay, let me mute the audio. Have you got the email from me?
Which email are you referring to, Ali?
I have sent the email with the PPT.
No, yet to get it, Ali.
Okay. If you have not received it, okay, then I'm going to send you the OneDrive link where you would get just you'll get the content of the talk. And is my screen shared? Are you guys able to see the screen well and fine?
Yes, Ali.
Perfect. Okay. So please mute yourself and we start. I'll give last 5 minutes for you guys for questions. Okay. In any ways, the rules of the training is just the same. You can interrupt me wherever you want to ask me to elaborate whatever you want me to elaborate. So here we go. Machine learning. So this is Mr. Human, okay, and he learns from experience. And this is how machine used to learn from commands. And now we have a humanoid, okay, which learns from data. So the machine learning is the learning from data. Data which can be interpreted as an experience of the machine. Here's a definition that you would most likely to see in most of the websites, most of the books of machine learning. The language which might be different, but the gist would be the same. Machine learning is an application of artificial intelligence that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. Okay, which means self-learning. Machine learning focuses on the development of the computer program that can access data and use it for themselves. Okay. Uh, Another way to say self-learning. The process of learning begins with observation or data, such as examples, direct experience, instructions, in order to look for patterns in data and make better decisions in future based on examples we provide. Training set, which we were talking about. So what we are talking is one more line. The primary aim is to allow the computer to learn automatically without human intervention or assistance and adjust action accordingly. Adjustment. Okay. So what we are talking about self-learning system. How and what is the mode of input in those self-learning systems? It could be vision, it could be audio, it could be the situational data, or the data that it has swallowed. So the big question is what happened to the human evolution that it has stepped to a kind of learning which is called AI learning, machine learning. What is happening to human evolution? What is happening to the anthropology? Okay, of the human cognition. So why human development need machine learning? Before we move to how machine learn, we have to know why it learns. Okay, that's a very natural query. Why we need to learn? Okay, so so here's the answer. uh, a government wants to build an airport, okay, at a place. Fine. Okay, it wants to build an airport at a place. Now, while taking the decision of building an airport, okay, it would have to see an array of things which are quite disconnected from the reason why they want to build an airport. Okay, for example, for whether it is affecting the water. So this is just for the sake of argument. Don't imagine it's true. Okay, pollution and resources, global foresight and decision making, global convergence. I mean, these things would look disconnected to you, but what I'm saying over here is that while creating an airport by a government or by an institution, okay, they would have to see loads of angles, okay, to decide whether the airport needs to be built or not. Okay, fine. What trade-off are we talking about? We need, okay, to build an airport, we just do not need civil engineering. We would require to step into other areas of knowledge, okay, a curated area of knowledge to fathom the effect of the airport that is going to be built. Agreed? Which means that even for the decision to make an airport, we would require something which is interdisciplinary. Okay, so can one single body, or institution, could take that decision of building an airport? Okay, difficult. So we need more intelligence. Okay, so there are factors, okay, of importance that we can actually be put in X and Y. Okay, and these factors are imaginary factors for now. Okay, and you can imagine these factors be anything. So I'm putting some factors over here randomly, and I am doing a correlation of those factors and building a line with. So if these lines, if my business if my business sense, okay, passes, or if my business decision is able to pass all these lines, I would think myself to be doing a good decision. But this is what I think I am doing a good decision, but not these factors, okay, which would be thinking whether my decision is right or wrong. Okay, because the difference between let me get the pointer. The difference between this, okay, and this is a little too much. So I am trying to favor something and not trying to favor the other. Okay. Now there is no way that I can draw a straight line on this particular plane. So you want to say that the airport can never ever be built on this particular ground. Big problem. Okay, big problem. How do we solve this particular problem? Okay, and this artificial intelligence is all about it. It talks about, okay, I say, is my answer right or wrong? I'm drawing a line. Okay, is my answer right or wrong? Okay, I say, I don't know. So what are we talking about? We are talking about something what is called multi-objective optimization. The entire base, the pivotal point, the axis on which the machine learning, the cognitive science, the AI, the computative analysis is based on is answering one question, that is multi-objective optimization. Now, what is that? Okay, we have smelled it. Okay, what it is, but we would not eat it, but we would see it a little bit more on it. So, multi-objective theory. What does a multi-objective theory say? Based on so many variables competing to each other, you might need to formulate problem with more than one objective, since single objective with several constraints may not adequately represent the problem being faced. Okay, so there is a vector of objective. Vector means array. It's not scalar. Vector means a collection. So this is represented as function of x, and the summation is the summation of first function of x, second function of x, and so on. Okay, to the point. Okay, where we recognize what is mean and what is mass. So finally, note, because function of x is a vector, if any of the component of x are competing, there is no unique solution to the problem. Instead, the concept of non-inferiority, see in Zeta, which is called Pareto optimally sensor, or must be used to characterize the objective. A non-inferior solution is one in which an improvement in one objective requires the derogation to other. To define this, the concept more precisely, consider the feasibility of omega. Now, let's understand. What do we do? Okay, to convince, okay, that your building of airport is not going to harm the environment. Okay, the party that is raising that particular voice or a question, we go to them, okay, and we try to convince them. Okay, then if we are not able to convince them, we try to enter into a trade-off, okay, which is best for the pollution and the development of that particular area. Okay, and there can be more mechanisms, okay, in which we can come closer to a negotiation. Okay, and how close we can go to a negotiation is again, okay, depends upon a lot of factors. Okay, how we are negotiating and all those things. Okay, but there should be an algorithm after which we can actually assume, okay, that the negotiation is done, and we can move to the other part, and then we can negotiate with that part, or we can negotiate together. But there has to be a path, okay, a path forward that actually gives a solution, and that path forward is not always a linear path that we would see in gradient, descending gradient and ascending gradient. So still hanging with the multi-objective theory, because multi-objective theory is one single theory, see, that is the motivation for solving all the problems, because you see, say for example, so somebody is facing cancer. Okay, cancer is a very deadly disease, and then he would have to go to take medicine. Okay, now this medicine that he's taking, okay, is also doing a side effect on his body. See, now what is, okay, the best medicine for this person can depend upon a lot of factors, okay, on his gender, on his genes, okay, on his age, okay, on his culture, and so on and so forth. Okay, if it happens to be a doctor who would be deciding upon on giving the right medicine, okay, he can be wrong, he can be right. Okay, but he might not be able to take into consideration all the factors of a particular person. Okay, and to find the to find the to find in consciousness, to find in to find in to find the to put all the factors together and to take a decision. Okay, and to take a decision that is less harmful, or the least harmful, and the most beneficial, is multi-objective theory. It can be described with the Nash algorithm, Pareto optimization. So there are a lot of algorithms around it. So finally, okay, the word of sanguine. So it requires an interdisciplinary knowledge. The second most important thing that has motivated the cognitive philosophers, the cognitive scientists, the computative scientists, is the dark data. Okay, what is a dark data? Dark data. Data that we collect on internet, or in an organization, or an enterprise, of employees, of products, about products, and we do not use it. They go into drains. Okay, and they lie somewhere. One type of such data is called dark data. The other type of such data, which we call dark data, are the data that is being generated by the machine. When you and I are talking, okay, we are generating n number of logs, the logs of the packet that's being kind of recorded as an impression on the internet. Okay. There are logs that are being generated by the servers, the routers, okay, the middlewares, okay, the hardwares, okay, the n number of things that's around us. These logs, once generated, are present. They do not get destroyed in the world of internet. And these logs, okay, these data are deprivative in making us take right decisions. They're creating noise, okay, in actually putting in a new system. So it becomes imperative, it becomes necessary right now to have an understanding of those logs, okay, and to use those logs for our advantage. So it has been estimated that in 2050, 80% of the data on the internet. Yes, somebody saying something, please? It has been estimated that 80% of the data on internet in 2015, okay, in a survey, where it has been estimated that it is a dark data. So understand, okay, the dark energies are responsible for us, giving us gravitational forces and making changes in the gravitational forces and whatnot, from our genetics to our to the cosmic rays. Okay, these dark data can draw a very similar logic, or can be drawn on the similar analogy. So you can see these dark data was not visible until we had the mechanism of big data. So big data and the nano computing and the supercomputing and the ease of computation and the high octane processes that we have, okay, has given a clue, okay, what dark data is. Now, do you think we have understood dark data? Okay. No, we have not understood dark data. We are scratching it. Okay, we're scratching it. For example, okay, the use of dark data that you see around you is that customers' patterns. Okay, customers' patterns. And the mail that I sent to you, okay, about a book, and that book is being kind of advertised to my inbox or to my YouTube, okay, is not a kind of a coincidence. It's not that the prayer have been heard by God. Okay, somebody has heard below God. Okay, and these data were considered dark data. Okay, but now not. So I've spoken about dark data problem. Okay, the problem that it is causing. Okay, see the amount of space it's occupying on internet. Dark data has got
Hello.
Go ahead.
Sorry to disturb you. So dark data is nothing but just an unstructured data?
Yes.
Is it more than that?
Yes, it is an unstructured data that could not be read, okay, through the current format, okay, or the computing system that we had. Not the current, the recent computing system that we have.
Okay. Would you please? I feel like, as far as I know, I feel like both big data. What is the difference between big data and dark? Because big data is also something which is unstructured, right?
Right. Okay.
So how does it differ from dark data? Yeah.
Okay. Good question. Okay, I'll answer this. Okay. We say that a big data is could read unstructured data. Okay. However, in order to read the unstructured data, it has developed some structured systems. Okay. Which is nothing but the different type of algorithms. Okay. Which are pattern-based algorithms. Okay. Now there are pattern-based algorithms which we have implemented in understanding. But do you think the pattern-based algorithms that we have developed is good enough to read all the type of data? The answer is no. Okay. The answer is no. We are only able to capture the data which are logged data. Okay. Now if you go for some of the softwares, okay, which are being used in the big data, I'll say go for Kibana, go for Splunk. Okay. They are the modules that uses big data algorithms in the background. Now these big data algorithms, okay, are trying to use unstructured data in a very structured way. Okay, first of all, if you say structured data, you are talking about SQL data or the Windows data. Okay, the file, okay, the tables, these are the data. but there are more data which are not in a file. Okay, of course they're in a file, but they are not unicoded. Do you understand? There is an ANSI code, there's a Unicode, there's a Unicode 6, there is a Unicode 12. Okay, so there are a lot of other type of data that are available, of which not all type of data could be read by the algorithms of the big data as of now. Lot of have been read, lot have not been read. Did I answer your question?
Okay, basically in short what you're trying to say is although both are unstructured data, there is some tool for handling the big data, some sort of algorithm. How can you interpret the data for people? However, we don't have any such type of computing to read this dark data.
No, the dark data is the data which we cannot read right now. Okay, so if we as soon as we get a tool to or algorithm to read the data from the pool of dark data, it doesn't become a dark data. We can categorize into unstructured data or whatever. So there would be again some data left in the pool. Okay, and this data is called dark data, and it's huge. It provides a huge opportunity to make money. Okay.
Can you give us any such example in the real life or real world where we call some data as a dark data? I mean, I might have missed if you have already given.
Okay. Earlier, when we used to send an email, I just spoke about it. When I used to send email to somebody, okay, that data was not considered important, because while sending an email, a series of activity would happen on the internet, and that data that get generated were considered not that important, but those data were getting recorded. Now we are using this data to recognize your pattern of purchase, okay, or your point of inclination towards a particular subject. You understanding how you search? Okay, your searches were not so considered so important. Now they have been read. Okay, how you are searching, what you are searching, what is your poignance, what is your inclination, what are your interests. Okay, so these are if you do not use them, they would go into the pool of big data, dark data. Did it answer your question?
Yes, thanks.
Thanks. You're welcome. So dark data is gone. So we are left with how much time? We are left with 20 minutes. Okay, and I have to deal with a lot of algorithms. Okay, how does a machine learn? Okay, of course, they learn through algorithms. So one such algorithm is decision tree learning. Okay, I'll talk about it. The other algorithm is associative rule learning. I'll talk about it. Artificial neural network. I'll talk about it. And then there is a deep learning. Then there is inclusive logic programming. Okay, I'll not talk about it. I'll just give you a short understanding about it. Inclusive logic programming is the programming of logic and machine learning together. It's an interface of these two. So the machine learning programs, if you see could be seen as artificial intelligence programming, and Watson is a very good example for this. You can embed Watson into your day-to-day code, okay, and be able to take advantage of Watson. Okay, for example, I developed a program which can translate what you say into a different language. Okay, do I have the logic for this? No, I do not. I did not have the logic. Watson, my dear friend, has given me an API. Okay, that API, it takes my input of speech as uh, as a stream. Okay, my input output of wave as a stream, convert it into a data stream. Then that data stream, okay, would be going into Watson for translation, and then that data stream that has translated comes out to me as a converted or translated data stream. Now that data stream would again go into Watson for converting into a voice. Okay, and then I would get a voice. Okay, I speak in English, you speak in Chinese. We all can talk. Okay. The possibility, the stress, the surge of machine learning has happened because machine learning machines can actually do things very accurately these days. Okay, less than 5% of error. A human, an expert, also make something close to 5% an error. An expert, not an amateur. Okay, so 5% of an error are considered not so important, but it doesn't matter. It does matter in what area you make errors. Okay, that actually changes the context. But we're not talking about that. We say 5% of the error is negligible for machine. Okay, and it is on and on improving. So support vector algorithm. What the support vector algorithm does is that it tries to find, and if there are two problems, okay, two scattered problems, it tries to find how much area is free. Okay, so this is algorithms. Okay, let me have I not given you an understanding of algorithms? See, in a logical learning, what were our tools? Okay, say for example you are a developer of C# or you are a developer of Perl, Python. What were your tools? Your tools were if condition, okay, loops. Your tools were if, branching statement, looping statement, okay, input output statement, and your libraries. Forget about those libraries. Those libraries were not actually your tools. They were the supporter of your tools. But basically, the STD, standard input output, input output, your branching statement, okay, your looping statement, and your assignment statement. Okay, these were considered as your tools. Okay, in the same fashion, okay, the new generation of the programming, which is AI or machine learning programming, okay, has got tools. Okay, and they are its algorithms. I have chosen and selected, okay, some of the most popular and most used algorithms to talk about. Okay, now if you think or consider this is all that machine learning offers, okay, I'm sorry, there are much more. Okay, however, they are correlated. Okay, correlation is again an algorithm that is used by machine learning in a great in every kind of step. Correlation, because if you want to learn something, okay, you have to have a correlation. You have to have a correlation, descent gradient, ascent gradient. These are the algorithms that you would know. Okay, I have chosen few of them. Okay, and I'll explain few of it. Okay, so this is the support vector machine. Okay, this is a machine in which you would always look for an optimal block, okay, which separates two problems. Clustering. Clustering is like you want to open up Pizza Hut. Okay, let me have a pen over here. Okay, there are 3 algorithms that I have left. Okay, and those algorithms I would be talking in a lot of details in another 5 5 minutes. Okay, 5 minutes, so that I can give good justice to them. Clustering. Okay, say for example, well, if I have my pen up, can I write? No, I cannot write right now. Let me have. Okay, I want to open a Pizza Hut. Okay, and these are the people where I need to get the Pizza Hut up. Okay, then I would have to choose. Okay, say for example, these dots were not colored. Okay, so I would have to choose where I have to open Pizza Hut. Okay, for that I need to cluster what is the right word? Population. Okay, so I have to cluster the population, and that process of clustering the population, okay, is called clustering. Now, there are mathematical derivations of it, but I'm just giving you the example. Okay. Now, for example, Bison network. Okay, Bison network is the network of interrelation. I would not say interrelation. I would say what do we call when we say if A is B and B is A, we get a error in programming and in Excel. Okay, cyclic redundancy error, in which A is dependent on B and B is dependent on A. Okay, so which came first, the egg or the cock, egg or the hen? Okay, these are the problems that Bison network is able to handle. Okay, so it's if the sprinkler is on, okay, the grass was wet. Okay, so that is okay. Okay, if it rains, then the sprinklers would be on. Okay, then the grass would be red. If the grass were wet, okay, then it is not necessary that it has a sprinkle or it has rained. Okay, so these are the type of algorithms that the Bison network handles. Reinforcement learning. Reinforcement learning is a learning that happens from multitudes. Multitude means okay. I would do a reinforcement learning. Okay, to a child. I'll make the child touch a cup. Okay. Know the properties about the cup. Okay. Make it drink from the cup, and then make a noise from the cup. Okay. So there are different senses. Okay, from which I am constructing a complete image. Okay, and that is reinforcement learning, which means I am getting the information from various sources and somehow validating it and chaining it with one another. Representation learning and deep learning. Okay, when we will do deep learning, okay, these are very interconnected. Now, similarity and metric learning. Go ahead, please.
Sorry, would you please step back on deep learning? I would just like to see how deep learning differs from representation.
I am giving time for deep learning in another 2 minutes. Okay.
Oh, okay. Sorry.
I would go into deep learning deep. Okay. That's the reason the 4 algorithms that I have left. Okay. I want to go into that. That's the reason I'm shortening on these algorithms. Okay. So here is another example. Okay, of similarity and matrix learning. Okay. In this, what we do is we try to recognize the objects. Okay, we try to recognize the objects based on similarities. Okay, so for example, over here you would see it is able to categorize these. I mean, I have given this training set. Okay, and it has been able to find out which is a shoe, okay, and which is a kind of a a hunter shoe, okay, and which is not a hunter shoe, and then bellies and sandals, okay, it is able to recognize based on the similarity, okay. It is comparing one object with the other, and then finding out the deviation between one and the other. That if the deviation is too high, okay, then it might put it in a different category altogether. Okay, if the deviation is less than a threshold, then it would put it into one category. Now there's something which is called supervised and unsupervised learning. If you tell what is the threshold to this type of thing, okay, you will call it supervised learning. If you do not say it, okay, what is the threshold, and the system is able to find the threshold all by itself, okay, and do the categorization by itself, it is called unsupervised learning. First, dictionary learning. Okay, in this we try to, when we draw a line, okay, we try to see what is the density of that, what is the density on that particular line. So the example of this is you can see. Have I got my pen? Right. So this is the original image. Okay, I have taken up this original image and given the computer this image. Okay, and asked the computer to use a Sparse dictionary learning. Okay, and it has been able to regenerate this image. So this image is with lot of noise, and this image is without noise. Okay, so it has come very close to the real image. Generic algorithm. Okay, rule-based learning. I'm just trying to skip so that I can give more time to some of the other topics. Okay. One hour time is little too less. Okay. So first I'll go for decision tree learning. Okay. Somebody ask me some questions? Okay. Oh, come on. Yeah. So decision tree learning, okay, it's a very interesting concept of learning. Here I have compiled an example of binary search. Okay, and I do not have too much of time, but in 2 minutes I'll explain how this particular binary tree is working, and then in 1 minute I'll give you a very beautiful example of binary decision. Okay, so here what is happening is first in the training set I got 11. Okay, and in my supervised learning I have said that when I get anything greater than the one that I have, okay, put it on my right hand side, and when I get something smaller than that, okay, put it on my left hand side. Okay, so I get 11, and the next time I got 19, so I put 19 over here. Okay, the next time I got 4, I put a 4 over here. Okay, the next time I got 14. Okay, so I put 14 over here. Now the question is, okay, why have I not put 14 over here? Okay, I could have put 14 over there as well, but that would have become the case. The second case of probability means is in the binary tree as well. Okay, there would be multiple solutions. Okay, so I have put 14 over here. Okay, now next time I got 9. Okay, I put 9 over here. Now the question is, why did you put 9 over here? Why don't you put 9 over here? Okay, you can have put 9 over here too. I could have put it. Okay, but it would have been a different solution. my solution over here, okay, is an attempt, okay, in which both the trees are balanced. Okay, if the trees are not balanced, okay, then my solution is wrong. Okay, so in order to balance my tree, I would have to see where I am choosing the where I am putting the values. Okay, now I put to 6. I get 6 over here and 10 over here. So this is a binary tree solution. Now using this particular thing, okay, using this particular algorithm, you have seen this particular algorithm. Now how does a computer use this algorithm? Okay, say for example, I have thought of a number. Okay, I have thought of a number. Let me just delete it and erase all this. Okay, I have thought of a number, and say for this, for as a matter of fact, randomly put my number as 50. What number should I put? 59. 59 is okay. Okay. So how does a binary thing would work? I would ask, what is the number have I thought? Okay, so it would ask first, is it greater than 100 or less than 100? I'll say it is less than 100. One question. It's less than 100. Okay. Okay. So if is it greater than 50 or less than 50? See what I'm doing. I'm going just half. Did you see this part? Okay. Okay. So 50. I'll say it is greater than 50. Okay. So I understood it is between 100 and 50. Okay. Now the next question that I will say, is it greater than 75 or less than 75? Okay, I'll say it is less than 75. Okay, fine. What is the half of 75? I'll say if it is greater than 60 or less than 60. I'll say it is less than 60. Okay, fine. If it is greater than 55 or less than 55, okay, I'll say it is greater than 55. It is greater than 55. Okay, then I will say if it is greater than 55, okay, then if it is greater than 57 or less than 57, I'll say it is greater than 57. And if then I will say, is it greater than 59 or less than 59? I'll say it's 59. I have found the number. Okay, and how did I find this number? I have found this number using the same binary tree that I have just demonstrated in front of you. Okay, so binary tree, binary tree can be classified into two types. Okay, and it is not that the data scientists have actually invented binary tree. Binary tree was there ever since. Okay, we started to classify things. Okay, so there is a classification binary tree. Classification binary tree. You can remember Charles Darwin. Okay, the origin of species. He has given an entire classification of the species. Okay, through this particular algorithm. Regression algorithm. Regression algorithm can predict, okay, the real number of the output. I'll show you the regression. Here is the regression. Okay, the example of regression that I have compiled. Do you see the bar moving? I'll show it again. Do you see the bar moving? Okay, this is what it is doing. It is trying to find a mean. Okay, and then trying to find the difference in the between the points and the mean. Okay, and what suits the best, okay, of the mean of the difference is the regression. Okay, did you understand? Now the next example, associative learning. Okay, associative learning is an example in which, okay, we would say that a particular thing, okay, a particular thing is connected to a particular thing, okay, which means that in this particular training set, okay, you can easily see that if a person purchases bread and milk, he would purchase butter. Okay, I'm sorry. If he purchases bread and butter, is going to purchase milk. Okay. So based on the training set that we have got, we can actually deduce a particular theory. Okay, and that is called associative learning. Because, guys, if I take 5 more minutes of your stipulated time, you would not punish me, correct? Okay, I think I would have to take 5 more minutes beyond my time. Is that okay with you guys?
Fine.
Surely.
Yeah, we are good.
Fine, perfect. So here I give you an example of associative learning. Now, here I have to stop. Okay. Let it go. So when a user selects something, okay, when a user selects something, and when he is selecting, in a combination he is selecting A, B. When he's selecting A and B, he's selecting C. Okay, so the reason for which he's selecting C can also be applied to the user. So when he is selecting X and Y, okay, he would be selecting Z. Okay, if C and Z, okay, can somehow be associated or can somehow form a relation with A and B, okay, and X and Y can form a relation with Z. Okay, and then if we can establish a relation between X and Y and A and B, okay, then that type of learning is called associative learning.
Sorry, Muhammad, to interrupt you. Are you showing something in the screen? Because I just see the same graph. I just see the same graph on your screen, the figure 4. The regression one which you were talking about, the population versus stuff. Are you showing some other thing on the screen?
Yes. Lot of things I had shown.
Because, or any other guys are you able to see, or just me?
What do you see on the screen right now?
It's just a ramp function. Just a linear curve.
On my screen, I see artificial neural network. How many of you?
Yeah, that's what we see early. Artificial neural network.
Yes.
Okay, probably something wrong with my. Okay, thank you. Sorry.
No problem. I like your interruption. I appreciate it. Okay, artificial neural network. Okay. Now, before I actually explain all these gyan to you, okay, let me take you to. Just read through it, okay, and I'll explain it to you. Lot of text, okay. This is a small video that I have captured, okay. Like to show it to you. That's right. here's a biological simulation. Okay, here's a neuron. Okay, and neuron collects information from various sources and give this information from this particular part, okay, to this. And when the neuron is sending the information, okay, it kind of filters the information in multiple formats. In the same way as there are inputs that are happening on the screen, okay, and then that is going to the output. The same thing can be done with the polynomials. Okay, but when you are doing it with the multiple things, then you are forming a multi-polynomial. And when this input and output theory, okay, can be kind of recasted, then you are able to create a network of polynomials. Okay, and when you are able to create a network of polynomials, okay, then that network of polynomials, we call it as what? Neural network. Okay. So this is what the explanation this particular slide is giving you. So it's mesh, okay, and it gives you a 3D solution. Why it is giving you a 3D solution? It is giving you a 3D solution. It is because it is multi-layered. Now, deep learning. You wanted to know deep learning. Okay. First of all, okay. I think I saved myself from getting embarrassed going beyond time, but I think I have gone embarrassed too. It's 3 minutes beyond my time. But what I'll do is I'll take another 3 minutes of your time, okay, and understand the deep learning concept, okay. Now, for example, okay, you are a camera on a highway. There is a camera on a highway, okay, and this is supposed to read the number plate of on your computer, on your car, truck, okay, and bike. It's a highway. Okay. Now, I'm reading it, okay, to know that how many vehicles are going, one, okay, and what type of vehicles are going. I'm also there to check the number of wheels of the truck, okay, because I have to decide upon the toll for this particular bridge, because if there are 8 tired vehicles going, 16 tired vehicles going, 16 tired or wheel, whatever you say, say 16 wheels vehicle going, 24 wheels vehicle going, I'll have to adjust to that particular toll. Okay. Now, how does this happen? This happens through deep learning. Okay, deep learning is the hepatic learning. Hepatic means learning through contours. Okay. Learning through contours. So you are learning through pictures, okay, and the contours of the pictures, okay, and that is called deep learning. The algorithms for the deep learning, the most kind of choicest algorithm for deep learning is the convolution neural network algorithm, okay, and it is very difficult to explain the convolutional neural network algorithm, but I'll try to explain it to you. See, here are the training sets. In this training set, I have cars, okay, trucks, and other things, okay, and I would have to identify what is a car, what is a truck, and what is the bike. Okay. So to identify what is what, okay, I would have to compare the two. And how would I compare the two? I would be able to compare the two through their pictures. Okay. through the pictures of the training set. Okay, videos, pictures, whatever. And the difference between the difference between a car and a truck, okay, would be put into a variable. Okay, and then another set would come. That would be a scooter. Okay, then there would be another variable. Okay, and so on and so forth. Then you would use the technique which is called similarity learning. Okay, to identify and categorize it. Okay, but the magic of the deep learning is when you are able to identify. Okay, when you are able to identify by a particular object. Okay, through its contours. You getting my point? You are able to recognize an object, okay, through its contour, through its hypatics. Okay, that is called a deep learning. Now, over here, okay, if you see in the convolutional neural network, it is able to see this particular pinhole is able to see this part of the car. Okay, and then it is then this has been this has gone into a processing bar. Okay, and then another processing bar has come. Okay, and this has magnified it and understood it. Okay, and taken information from it and then moved it to the other one, the other block, and then the other block, and then the other block, to the time, okay, it is able to break that particular area into something that is sensible. Okay, and then once a particular thing of that sort would come in, it would take that join, okay, that information that it has gathered, match it, okay, and see if it is matching or not matching. Okay, and then if it has matched, then it would look for the next closest block that it has matched. Okay, and then it would make a kind of an assumption. Okay, what a particular car would be. This is slightly different from similarity learning. Okay, but it is in sync, or it is very much like that. In similarity learning, you take the object as an entirety. Okay. In this, you do not take the object as an entirety. You break the object into very small pigments. Okay. I'll show you the picture that I have gathered for you. Here is the picture. Here you can see it has broken down the face, okay, into its a small component, okay, and then is able to recognize the face. Okay, so for it, it focuses on a small unit, okay, break it, okay, and then keeps it, and then it forms its own hypothesis, reassembles it, okay, and generates a picture out of it, okay, and then it is able to recognize. It also requires a training set. Okay, so this is all for my presentation in AI. Okay, hope you guys liked it. Okay, if you have any questions, just fire on to me. I'll be very happy to answer them. What are you guys giving me?
So, Mohammed, is it deep learning? Is it only associated with images, or else the same would be applicable for when you're recognizing a speech pattern or data pattern, whatever?
Exactly. It is. it is related to hippocampus. Okay. With the contour, with the speeches, in the speeches, if you say from the speech, it is able to draw to the conclusion of the mood. If it is able to draw a conclusion of the gender. Okay, and other factors as well.
Okay. In short, this is something which is an data feed to a machine learning system. All this, I mean, deep learning is something what you are perceiving from the external world and giving a data to the machine learning, where in the machine learning you will be writing your own logic based on the data, take your decision and do the job.
Yeah, somewhat.
Right. And one last question on this is, you might have
one question that I want to ask you. What are you guys giving me? I don't have a clue what you guys are giving me. You're giving me your short IDs. What I am going to do with your short IDs? I have given you the link. Okay, if you do not fill up the link, okay, I might not be able to do the attendance for you. No, you do your attendance. If you want, I can give you the link again. Here's the link. Okay. Do your attendance yourself, please. Go ahead, please. Yeah. What's your question? Hello. Please go ahead with the question.
Sorry, I just have one last question. I might have missed when you were trying this part. I understand what is the difference between the deep learning and machine learning. I just wanted to know where does artificial intelligence stands, how it differs from these two. I mean, a combination of machine learning and deep learning. How is artificial intelligence differs from, because I feel like, I mean, everything is the job is being done with machine learning plus deep learning. How come artificial intelligence differs from these things?
Okay. See, these are the communities. Okay. Basically, everything is so interconnected and cobulated. Okay. But I'll try to make a sense out of your question, what you have said. Okay. Okay, and that is a genuine question. A lot of people ask me, okay, is the machine learning and AI the same thing? Okay, is this the question that you are asking? See, when you solve, okay, the problem with machine learning, okay, and the algorithms that you make for machine learning, when they are put in a kind of a package for you, okay, then you call it artificial intelligence. Okay, like the example of Google deep learning. Okay, it's a package of AI. Okay, Watson, it's an AI. It's an AI that definitely works on machine learning. Okay, but it's a package for you. Okay, and then there are different packages. If you had done my talk on cognitive science, okay, then you would have definitely got the answer for it. I have dealt with the machine learning from the very basic zero. Okay, the conceptuation of the machine learning I have dealt with, taking it from the cognitive science to cognitive computing to multi-objective theory, and then to machine learning, and then to Watson. Okay, I'll try to find the talk for you, okay, and send you the hyperlink. However, the answer to your question is very simple. Okay, when we are packaging it, okay, they become an AI. Making sense? Hello? Hello?
Sorry, was on mute. Yeah.
Yeah. When you're packaging it, okay, when you're packaging it, when you're packaging a solution, okay, it becomes an AI, artificial intelligence. Okay, for example, I gave you an example of my voice synthesizer. Okay, wherein I speak in English and I can choose Chinese or Japanese or whichever language I want to choose. Okay, so I'm using AI. Okay, in the background of AI, it is using machine learning. Okay, but I don't care about machine learning. I use AI. Okay, so there would in the coming future there would be consumer of AI, machine learning, who would be an AI programmer, okay, and then there would be a machine learning programmer, okay, who would be developing algorithms and mathematical models for it. Okay, so we fall in the category where we would be using a logical programming and and machine learning, and we would call it AI program.
Okay. Yeah, sure. And do you have any links to start for data science? I mean, to start something to. Do you have any preferred stuff to start?
We can talk offline on that. Okay.
Yeah, sure. Yep.
You ping me.
Thanks.
My. Any question from anyone else? Yes, Krishna, you have a question?
No, nothing.
Okay, can we have more sessions related to this topic? Hey, I am doing a C# training right now. Okay, and then after that, I would be doing web training, ASP.NET and MVC training, and after that, I will be doing a training on basic mathematics, which is statistics. Okay. There I would be doing the statistics for machine learning. Okay. So you might have to wait. Okay, because I am one person and I cannot devote too much of time into training. Okay. So once this is over, I mean I'm doing a Windows technology. I'll do the web technology. Okay, and then I'll do a mobile technology. Then I'll touch machine learning. Okay, I'll do Xamarin. I'm doing C# right now. I will do MVC. Okay, and then Xamarin, and then maybe .NET Core, and then I'll touch this. Okay, maybe in February you can be looking forward to this particular training. So far talk is concerned. Okay, if the training department throws any more questions to me, any more topics to me, okay, I'll do the talk.
Okay, thank you.
Any more questions? Okay, do your attendance yourself. I would just forward this link. Okay, so thank you. Bye then.
Thank you. Have a good day. Bye bye.
Have a great day. Bye.